Hey guys, today we're going to learn how to write repeating decimals as fractions. Repeating decimals are something that you guys are familiar with. You know how to change fractions into repeating decimals, but you've never gone the other way around. You also know how to write just terminating decimals into fractions, so we can pull from what we know about that today. So I'll just remind you here about how to do this. So 0.3 repeating, to change that into a fraction, we have one decimal place out. I'm going to use my 3 as my numerator, and my denominator is just going to be a 10. 0 for one decimal place. And then for 0.25, I'm going to use 25 as my numerator. And now I have two decimal places, so I need 2 zeros for 100, and you can simplify to 1/4. So that's just a reminder there. Powers of 10, the number 10 is really important for writing repeating decimals as fractions. The number 9 is going to be big for us today in writing repeating decimals. So terminating decimals, 10 is important. Repeating decimals, it's going to be the number 9 that we're going to see over and over. So speaking of 9, I want to remind you of one more thing before we start on today's notes that you've probably learned about in the past. Your divisible by 3 rule. So when I have a number, that when I add up that number, the sum of their digits. So if I have the number 75, 7 plus 5 is 12. And we all know that 12 is divisible by 3. So the rule tells me that means 75 is divisible by 3. We all know that's 25. So a 3-digit number looks like 1 plus 4 plus 4 is 9. Well, 3 fits into 9. Therefore, the rule tells me 3 fits into 144. So it doesn't necessarily give me the answer to the division problem, but it lets me know that it is divisible by 3 in order to simplify some of those bigger fractions. So I'm going to come back up to the notes. If you guys have these printed out, that's awesome. If not, you can just jot down your own notes. This is actually a really easy set to kind of make your own on some scrap paper. And I have the first 2 blanks filled in for you. Repeating decimals are rational numbers. And we'll learn next week when we start classifying numbers into categories. Rational numbers mean they can be written as a fraction. Notice how the word ratio is in there. So ratio means fraction, rational means fraction. So let's get started. I want to show you today 3 different tricks that I've learned over the years. There's a way to do it out with equations that I'll show you at the end that explains why all these tricks work. But for me, if it were me doing the math, I would be using the tricks, so that's how I want to show you. So I have 3 separate tricks, and they kind of get more intense as we go up, I'll say. But we'll start with the easy ones, and I bet everyone already knows that 0.3 repeating is 1/3. The way we would use the rule when I have an entire decimal that's repeating. So after the decimal place, the number 3 is repeating over and over and over again. For this one, 2,4 is repeating over and over and over again. And for this one, 0,14 is repeating over and over and over again. So that this trick is only working when the entire decimal repeats. I'm going to take the number and put it in my numerator. So I have 3 on top. I have 1 decimal place that's repeating. So that 3, 3, 3, 3, 3. Remember I said 9s are going to be huge today. I'm going to use a 9 to represent repeaters. So I have 1 repeater. I'm going to put 1 9 in my denominator. And that simplifies to 1/3, which you guys probably already knew before we did that trick. So 0.3 repeating, 1/3. For this one, I have 24, 2,4 repeating, so I'm going to put 24 in my numerator. Now I have 2 places that are repeating. I have 2 and a 4 repeating over and over. I'm going to use 9s to represent both of those digits. So I'm going to have over 99. Now I'm going to reduce. I know that 3 fits into both of those. So when I reduce, I'm left with 8 over 33. And if you guys type 8 divided by 33 into your calculator, you will see that I end up with 0.242424 going to the end of your calculator till it runs out of room. I should also note too that if we were doing this in school, we would not have a calculator. So try if you challenge yourself without one and see how it goes. So next, I have 0,14 repeating after the decimal. So I don't need to write that 0. I'm just going to write 14 in my numerator. And down bottom, I have 1, 2, 3 decimals repeating. So I'm going to use 1, 2, 3 9s to represent those repeaters. and I would be done. I can't simplify that. So I have 14 over 999. So next I have a new trick. I'm going to move down to my next row if you're following along in the notes. And the next row tells me to put the repeating digits over 9s and add the zeros when I have 0 placeholders. So let me explain what that means. 0 placeholders mean that the whole decimal is repeating, aside from maybe some zeros out front that are not going to repeat with it. So here I have 1 0 that's not going to repeat. Here I have 2. And here I have 2. And the difference between this row that I'm looking at now and the row that we just did before, like this one for example, this one would be written out 0.014. So that 0 is going to repeat with the digits. Down here, if I were to write this out, I have 0.00, only the 2 4s repeating over and over again. So those are not repeating, they're 0 placeholders. So the rule tells me use a 9 to represent a repeater, and I'm going to tack my zeros on at the end. So for this, my digit in the numerator is going to be a 3. Down bottom, I have 1 repeater. I'm going to use a 9 to represent that repeater, and then I'm going to tack my 1 0 on at the end. And I can simplify to 1 over 30. Next, this one's almost the same, but I've got an extra 0 placeholder in there. I'm still going to use a 3 in my numerator. I'm going to use 1 9 to represent that repeating 3. And my zeros, the 2 of them, tack on at the end. When I reduce, I'm left with 1 over 300. And last but not least, I have 0.0024. I'm going to have 24 in my numerator. I have 2 digits that are repeating, like I wrote it down here. Those are repeating, those are repeating, those are repeating. So I'm going to use 2 9s to represent those, and I'm going to tack my 2 zeros on at the end. Now this one's a little trickier to divide or to simplify, and that's why I mentioned the 3's trick in the beginning. I know that 24 is divisible by 3, and I know that 9,900 is divisible by 3. And I can tell this one we all know it's divisible. 3 times 8 is 24. Down here, if you didn't pick up on it right away, 9 plus 9 is 18. And 18 is divisible by 3. Therefore, I know that it fits into there. So I'm going to reduce this to 8. It's going to be 8 over 3,300. And now I'm seeing that it's even. So divisible by 3 and even numbers are how I typically reduce it. And when I end up, when all is said and done, I end up with 2 over 825. So if I type that into a calculator, if you try that at home, 2 divided by 825 should look something like this blue line in your calculator until the calculator runs out of space. I have one more trick to show you. The last trick is kind of like the most complicated out of all of them. It's a little more to remember. And I'm going to start off by showing you what type of numbers I'm talking about. The whole decimal is not repeating. So here, that 1 is not repeating and it's not a 0. The zeros we have that cool rule for. Here we don't, unfortunately. I have a 1 that I have to deal with here. Here there's a 2 that's not repeating. And here I have another 1 that's not going to be repeating. So I've got to watch out for those. So the rule tells me, and I'm going to write it out as I go, it says the denominator, for the denominator, I'm going to put as many 9s as you have repeaters. I have 1 repeater here. It's that 5. It looks just like kind of like the ones up above. I'm going to use a 9 to represent that repeating decimal. Now I have a 1 that's not repeating. So this rule up here, if I'm looking at the notes, it says put as many 9s as you have repeaters and add zeros for the non-repeater. Well, this 1 is not repeating. I'm going to use a 0 to represent that. So far, this is very much like the one that we did up above. For my numerator, I'm going to take all of the decimal digits. If you're looking at step 2 on the notes, it says take all of the decimal digits and subtract the non-repeating digits. Now, what that looks like is I have all of my decimal digits, 1, 5, and I'm going to subtract my non-repeater, my 1 here. So when I simplify this out, I end up with 14 over 90. And now I'd like to reduce, and I end up with 7 over 45. And you can check it again in your calculator. 7 divided by 45 should look like 0.1555 for the rest of your screen. There might be a 6 on the end there. That's because your calculator is rounding up, not because it's actually a 6. Over here, I'm going to go ahead and do another one. I'm going to start with my denominator. That's the easier part. I'm going to use 9s for my repeaters. I have 2 repeaters here, so I'm going to use 2 9s. And I have 1 digit that's not repeating. I'm going to use a 0 to hold my place there. For my numerator, I take the entire decimal, so 236, and I'm going to subtract the non-repeater, the 2. 236 minus 2 gives me 234 over 990. And again, guys, this, at first glance, you might be like, oh, what can I divide by? They are both even. I also see that both of them are divisible by 3. And I know that because 2 plus 3 plus 4 is 9. And I know 9 is divisible by 3. Therefore, 234 is divisible by 3. I also know that it's divisible by 9. So I'm going to go ahead and just do that to save some time. It's divisible by 9 and gets me 26 over 110. And when I notice that both of these are even, so I divided by 2. And I end up with 13 over 55. I have 1 left, and this one I wanted to include in the notes for you because I have a whole number out front. So I'm going to deal with that by just kind of writing a big 2 so I don't forget about it. And I'm just going to figure out what 0.15 repeating is. And I'm seeing now actually that it's the same as what's over here. So the only difference between the one in the left-hand column and the one that we're working on now is that I've got a 2 out front. So it's 2.15 repeating instead. So I already know that my fraction to represent 0.15 repeating is 7 over 45. So I'm just going to use that over here. Now, if we were in class and in the Google form, it's not having you keep it as a mixed number when we're writing it like that. We want to put it in an improper fraction. So just a reminder on how to do that, you do 2 times 45 is 90, plus 7 is 97. So 97 would be my numerator, and I keep it over 45. So that is everything there is on the notes that you need to know. Now, a lot of you like to ask why, and if you wanted to look at these steps down the bottom of the notes, this is one example, and it shows you the equation thing that I was telling you about. I'm going to show you a different one. We'll use, we'll do this one using that x equals method for the equation, and then we'll see that it ends up being 7 over 45 anyway, which is why that trick can work. So for this method, and you're continuing to watch if you want to know why these tricks work, and maybe it'll help you remember what the tricks are. So for this one, if I'm trying to change 0.15 repeating into a fraction, the first step for this method would be to say I'm using, I want to change 0.15 repeating. So I'm going to say x is equal to 0.15, and the 5 is repeating. So I'm going to write a few of them. And notice up here, guys, I have 1 repeater. So if I have 1 repeating, I'm going to use a 10x. If I have 2 digits repeating, you would use 100x here. So I'm going to use 10x. I'm going to write it above. And when I multiply the left-hand side by 10, remember going back to equations, pull from that knowledge that you have. If I'm multiplying the left side of an equation by 10, I have to multiply the right by 10. And when I'm multiplying by 10, what I'm really doing is moving that decimal place over 1. So I have 1.555. And I'm just writing a few of them. You could write just like 3 if you wanted. You could write 10 if you wanted. It doesn't matter how many 5s you use. Now I'm going to subtract both of these equations. So if I do 10x's and I take away 1x, I've got 9x left. And here I'm going to subtract those, cancel, 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 cancel. 5 minus 1 leaves me with 4. 1 minus 0 leaves me with 1. Now I'm almost there. This is just a one-step equation. You guys all know how to deal with this. At this point, I have 9 times x. that means I'm going to divide by 9. And I'm also going to divide by 9 on the right-hand side. And this is a fraction. I have 1.4 over 9, which is good. We're close, but we never want to leave a decimal in our fraction answer. So I'm going to move my decimal over. And if I move my decimal over on top, I've got to move it on bottom as well. So I'm left with 14 over 90. I'm going to use a 0 to fill in that place there. And look at this in green here, 14 over 90. And using that trick, way easier up here, as long as you can remember it, 14 over 90. I'm getting the same thing, which will reduce to 7 over 45. So hopefully you guys like the tricks, because this is the alternative, and I'm happy to help you more with that in Zoom if you like that way better. We can go more in depth with that. And I just wanted to show you one more quick thing. Mrs. Rumson made a funny TikTok about it, so I wanted to show you what she's talking about. If I do 0.9 repeating, this will be quick, 0.9 repeating, using the trick that we did at first, my whole decimal's repeating, therefore I can just put it over 9s. So 9 over 9 is actually equal to 1. So mathematically, 0.9 repeating is actually equal to 1. So that's her TikTok video that we're going to post for you guys. So if you have any questions, make sure you remind us, you email us. If the Zoom hours don't work, let us know. We'll find some more time to help you out. I hope you have an awesome day, and we'll see you soon. Bye-bye.